Greetings. All right, so we're going to do problem 418 in R here. So the first step is to get the data entered into R, okay? So this is on, well, it's a different, on the standard text, it's on page 241. I forget the page number on the custom publish, okay? And basically what it is a data set of how many squares a rat had taken. Okay, so researchers interested in learning about the exploratory behavior of a particular strain of rats. So he's taken 20 such rats, deposited the rat individually, one at a time, on a box bottom, on the bottom of a circular box. The floor of the box has been laid off with a grid, and the number of squares in which the rat stepped in a 30-second interval is recorded. This is commonly used to index exploratory behavior called the open field test. The following data are the number of squares for each of the 20 rats. Okay, now you got to be careful here because a lot of people get confused with this. The first row is not data. That's just identifiers to tell you the different rat number. The lower row, the number of squares, that's actually equal to the data. In fact, I shouldn't call it rat here. That's going to be kind of confusing. Let's call it num squares. Okay. That's probably a better idea than calling it rat, because then you think I'd want to enter that top row, and I don't. I really want to enter the second row, okay? Now they want us to make a frequency plot of the data. Now a frequency plot of the data could be done pretty quickly using the hist command, okay? So let's just go ahead and do this, execute that line, and then come here and go hist num squares. Okay, and do that, and we end up with the following. But the problem is, notice that it didn't give me a single bar for each of my my entries. Okay, in other words, notice it's given me between 2 and 4, between 4 and 6, etc. Okay, now we see that the range of our data goes between 2 and 11. Okay. So we could come up with the number of squares that we want there, and we could get the histogram command to work. But in the case where you have discrete quantitative data, it's okay to still use a bar plot. Okay, so we're going to go ahead and do that. I'm going to come in here and just say bar plot of the table of num squares. Okay. And when I do that, I get the following plot. Okay, now that is not a histogram; that's a bar plot. So notice that there's breaks between the bars, which in numeric data, typically we don't want that to happen, but that's okay because they were asking us for a frequency plot, and a frequency plot and a bar plot are actually kind of kissing cousins. You can think about a frequency plot as simply being a bar plot for quantitative data. That's a real good way of thinking about it. All right. Okay. Now, as usual, we got to do some guessing up of this. You don't want to just leave it like that. You got to do some labeling. Okay. So our X label is going to be equal to what? Well, that's the number of squares, isn't it? Right? Nope, better put in quotes. Oh, and spelling squares correctly would also probably be helpful. Okay, so number of squares. The Y label in this case is what? That's frequency. The main here is open field test for rats. Right? Isn't that what they called this thing? This is referred to as an open field test. So an open field is hyphenated here. And, oh, I don't know. Why don't we put some color in here too? What color shall we do it? Oh, let's make it red. My daughter would like that. Okay. There you go. All right. Now, they say state an appropriate description for what the plot tells us about the open field test response for these rats. To guide you in the writing up your description, recall the paragraph's description of the ice cream cone prices given in example 4.6. Okay. So if you haven't read example 4.6 yet, please go back and do that. But let's take a look at it here. What should we say about the shape? What is the appropriate description of the plot tells us about it? Well, what do we see? We see that the majority of the rats, if you were to kind of think about a smooth curve over the top of this, stepped on around 7 squares. So the center is around 7 squares. The spread of our data ranges between 2 and 11 squares, so we're going to talk a little bit about the spread. Don't see any outliers in here. It doesn't appear that we've got any unusual events, and the shape appears to be roughly bell-shaped, okay? So we have kind of a bell-shaped curve. So the four things that we typically want to talk about with respect to a distribution or what a plot tells us is we want to first, probably the easiest one to go for is shape. And the shape is equal to bell-shaped, okay? And then the next thing we'd want to talk about is what do we say with respect to the center. The center here is about 7 squares, right? So in other words, our average number of squares that we saw our rat step on was about that many. Okay, what about spread here? What about the spread of our distribution, or the spread of our data? Well, our spread runs from what? From 2 to 11 squares, okay? So that's a pretty fundamental there. And the last but not least, outliers, we would say none, doesn't appear to be any, okay? Now I just ticked them off kind of bullet points, but that's not a bad way of doing it. Okay, well hopefully that helps you see how to do a bar plot of, or a frequency plot, excuse me, a frequency plot of when we have discrete numeric data. Not a bad idea to be able to do it that way. Okay, I'll see you all back soon.